overall goal of this temperature-programmed reaction method is to determine the deoxygenation performance of molybdenum carbide catalyst from the pyrolysis oil, model compound acetic acid.
This method can help answer key questions in the field of vapor phase upgrading using heterogeneous catalysts, such as those regarding catalytic activity and selectivity from pyrolysis oil model compounds.
The main advantage of this technique is the ability to test catalytic performance over a range of temperatures in a single experiment.
While this method can provide insight into catalytic performance with acetic acid vapors, it can also be applied to other pyrolysis oil model compounds, such as acetaldehyde, ethanol, methanol, and anisole.
First, remove a clean, dry quartz U-tube reactor from a drying oven. Once the reactor has cooled to room temperature, load a small amount of quartz wool into it using the minimum amount needed to support the catalyst bed. Using a clean, stiff metal wire packing rod, gently push the wool down the quartz tube to the end of the straight section. Next, mix 50 milligrams of molybdenum carbide catalyst with 200 milligrams of sieved calcined quartz chips to prevent channeling and to ensure consistent temperature through the catalyst bed. Using wave paper and a clean funnel, pour the catalyst and quartz chip mixture into the reactor, such that the catalyst bed sits on top of the quartz wool support. Then, gently push a second small piece of quartz wool on top of the catalyst bed, securing the catalyst bed in place.
It's important to ensure that the catalyst quartz chip mixture is homogeneous, and homogeneous mixtures can lead to channeling, temperature gradients, and an excessive pressure drop across the catalyst bed.